So in chapter 6, we're talking a lot about inflation calculation using the CPI approach. CPI approach versus the GDP deflated approach is a lot about looking at cost of living and how that changes over time. So this first question here that talks about Babe Ruth, a famous baseball player, earned $80,000 in 1931. Today, the best baseball player can earn 200 times as much as Babe Ruth in 1931. Are the best players better off than Babe Ruth? Well, to answer this question is if these people are earning 200 times what Babe Ruth is earning, what you have to be interested in to know if you're better off is how much was Babe Ruth was able to afford with 80,000, how many cars, how much food, how many of whatever he may be interested, houses, and so on and so forth, versus the people that are now earning 200 times that amount. We don't know how the cost of living has changed over this time period. Has it gone up 200 times? Has it gone up less than 200 times? There's a lot of information missing. So the people saying, the answer is saying yes or no, cannot say it accurately. So those two are out. And then it's one of these two that it cannot be determined. And without any additional information regarding increases in prices, what I was arguing, if we look at the other answer, cannot be determined because one cannot make judgments about changes in the standard of living based on changes in prices and changes in income. Well, you can make judgments about changes in standard of living based on changes in prices and changes in income, but the problem is here is we only have changes in income. We don't have changes in prices. Which problem in the construction of the CPI is the invention of pocket-size computers most relevant to? So 3 big problems that arise with respect to the construction of CPI that we're seeing in the notes is introduction of new goods, substitution bias, and unmeasured quality change. Income bias was not one of them. So it has to be one of these 3 answers. They're all there. While here, substitution bias is related to the idea that, let's say for some reason there's a drought that makes the price of bananas quadruple, you might substitute to another fruit. But the CPI that forces you to consume the same basket will not take that into account. This is not what we're talking about here. It's not a question of this has increased or decreased in price and we'll either substitute towards it or away from it. That's not what's going on here. Unmeasured quality change is doesn't really take into account a specific good that may improve or deteriorate in quality over time. But here, we're talking about an invention. So an invention relates to the introduction of new goods. If we think about something that was not available when the basket was constructed that is used to calculate CPI, and it's introduced a few years later, well, it can't be included for those years that it wasn't there, so it's that basket of goods would not take that specific good into account. It will be able to when we'll have sufficient amount of years that has that basket of goods available. Samantha deposits $2,000 into a saving account that pays an annual interest rate of 5%. Over the course of a year, the inflation rate is 2%. What happens at the end of the year? Well, this $2,000, if you multiply this by 1.05 to add this 5%, you'll see that it ends up being $2,100. So out of all these answers, Samantha has to have an extra $100 into her account. This is the nominal interest rate of 5%. So she ends up with $2,100 in her account, so $100 more than before. And over the course of a year, the inflation rate is 2%, meaning that something that used to sell for $2,000 will now sell for $2,040 because the overall cost of the goods has gone up by 2%. So normally most goods will go up by about that rate, so $2,040. Her account says $2,100. What this good that was $1,000 sells for $2,040. So her purchasing power has increased because she can now still afford that good that used to be selling at $2,000, who's now selling at $2,040, and she gets an extra $60. What is the basket of goods used to construct the CPI? So in this chapter, we've seen that to construct the CPI, Statistics Canada uses a basket of goods commonly consumed by an average consumer in Canada. And this basket of goods takes into account roughly 600 goods, and it takes into account different quantities for each of those goods to represent a typical consumer. So here, the average price of goods and services in each major category of consumer expenditure. Well, there's not 600 categories, there's less than that. So this is not good, it's an aggregation. We're still looking at goods. The goods and services typically bought by consumers, according to Statistics Canada surveys, would be the right answer. So 600 of those. So certain goods that are just too fancy that very few people consume are not in there. A random sample of all goods and services produced in the economy. No. When we look at what's being produced, we're thinking more GDP deflator, and it wouldn't be a random sample, it would be everything produced. Goods and services weighted by the ratio of expenditures on them relative to the consumption component of GDP. Once again, this is based on what they refer to as like a typical consumer. So the weight does not necessarily have to be relative to the consumption component of GDP, so this one would be wrong. Okay, we'll see how we could calculate CPI in this example here. So this is a kind of example that you could see on an exam. So this one will take a little bit more time, but if you were to have this in multiple choice format, sometimes you could eliminate a lot of bad answers quick. So if we look at this good here, we have 4 different goods, 4 different prices for the first year, 4 new prices for the new year, and we're asking for inflation rate as measured by CPI. So we always have to take into account how many units are bought. If we buy more loaves of bread, it's going to have a bigger impact than CPI, a bigger weight, and so on and so forth. So the thing that we have to keep in mind is that we'll have to multiply. So we'll have to look at the cost of this basket in the previous year and the cost of this basket in the new year. So it would be 4 times $1, 6 times 150, 2 times 6, 2 times 10. That would be my cost for or whatever this year is. And then again, 4 times 150, 6 times 2, so on, and I'd find the cost for this. Once I have the cost, the formula was inflation using the CPI approach would be the new cost over the old cost minus 1, close the brackets, times 100 would be, you would find which of these amounts it would be. So now looking at a shortcut. So here, if I wanted to see a shortcut on how to do this, well, if I just look at each good in question, I could have an idea what overall inflation will be. The first good has gone up by $1 to $1.50, it has gone up by 50%. Second good has gone up from $1.50 to $2, so a third of it. So this one's gone up by 33%. The third good has gone up from $6 to $7.50, which is a quarter more, 25%. And then this last one has gone up by 30%. So I have 50%, 33%, 25%, and 30%. So any amount that is below all of these percentages obtained or above all of them obtained, so anything below 25% or anything above 50% could be automatically excluded. So 20 and 24.4 are obviously wrong. Then between 30 and 31.11, it'd be a harder one to figure out because these are pretty close. They're harder to eliminate. My guess would be 31.11 based on the fact that there's just one that's below 30%, which is this one here. And all the other ones are 30 or above. So I'd expect the overall impact to be greater than 30%. But it would be hard to make that call. So if you were to calculate it instead, well, what would you have? So the cost, as I mentioned, in the first year, so the initial year would be $1 times 4. So that's 4 plus $6 times 150. That's 9 plus 2 times 6 is 12 plus 2 times 10 is 20. So my cost in that first year, 13, 25, 45. Obviously, I'm fast tracking here a little bit, but you get the idea. Here I have 4 times 150, so the new year is 6 plus 6 plus here I have $2 times 6, so 12. Then 750 times 2, 15, plus 13 times 2, 26. So this adds up to being 1833. And then 33 plus 26 is 59. Hopefully I didn't make any calculation mistakes here. So what would be the actual calculation? It would be that this inflation rate would have to be equal to 59 over 45 minus 1 times 100. If I take a second to calculate this, I could see that 59 divided by 45 gives me 1.3111 minus 1 will give me 0.3111 times 100, 31.11%, which is the answer that I guessed. So I guessed it. If I had time, I would verify it. And here I am verifying it, and that is the right answer. So hopefully that clarifies how to obtain all of these answers for this chapter.